Dr. Amy Hirons. I'm here at the Oceanographic Center at Nova Southeastern University. We're here at the boat basin today to talk about abiotic measurements. A, or lacking biology. What we're really talking about is the physicality of environments, both in the air as well as in the water. These are things like how much sun do we have, or cloud cover. Is it a rising tide, a lowering tide? What temperature is the water? How much salt or salinity does the water have? When you go in the field, whether you're in land, in the air, or in the water, what you want to know is, where are you? And the first thing that we use is GPS, or Global Positioning System. These little handheld devices or instruments mounted within a vessel or an airplane can give us an indication of latitude and longitude. For example, here in Fort Lauderdale, we are approximately 26 degrees north, 81 degrees west. We can plot our waypoints or a particular station we want to be able to return to. Vitally important when we're working in open water. We want to know where we're at. So today we're going to show you some of the instruments that we can use handheld in the field that can tell us things about the environment. One of the first measurements we would collect when we're in the field is we want to know which direction the wind is coming from. Commonly used instrument is called an anemometer. That's what you see demonstrated here. There's a larger version and a small version. Both digital, so they operate on a small lithium battery, so that you can get actual directional information as well as wind speed. So if you look carefully at these anemometers, they have a propeller in them that the wind will now generate motion. You can also see that there's a digital printout. So Bree, when you hold that anemometer up, can you tell us how quick or how fast is the wind blowing?
Currently, it is 0.13 meters per second.
So what happens when our batteries die and we don't have any information to tell direction? Well, one thing you can do is look around you. If there are trees in the vicinity, you can look and see which direction the palm fronds or the leaves and branches may be moving. Additionally, whether you're on a boat or near the coast, you might also see something like flagpoles. It could be flying the U.S. flag. It could be on a boat flying a dive flag. So now you can see the direction, but how do you verify that? You can use a manually held compass, or you can go back to our GPS, which also has directional information or a built-in compass.
When working in the water, oftentimes we are concerned about the visibility in the water column. What Laura has here is a Secchi disc. The white and the black offer contrast, so as you lower in the water column, you can actually determine if it is still visible or not. As you lower the Secchi disc in the water column, the white and the black offer contrast, so ideally, you would lower the disc until it just disappears. As we are in the boat basin, and it is relatively shallow, it probably won't disappear. The water clarity is pretty good. But once you have either hit the bottom or you have seen it disappear, make sure you grasp the line at the point where it was at the surface. Then, when you retrieve the Secchi disc, you can measure the line's distance to determine just how deep the water column is, or in this case, your visibility. Laura and Brianna are demonstrating this here.
Two major abiotic variables that we pay attention to, whether we're in a shallow creek or in the middle of an open ocean basin, are temperature and salinity. What Brianna is demonstrating for us is a handheld digital device that will measure both temperature and salinity. This instrument is called a YSI meter, simply named for the company that produces it. In her right hand is the actual probe that has the sensors carefully encased within the plastic. The cable itself can come in various dimensions or lengths. The first thing we can do by toggling through the various modes on the instrument is actually get air temperature. So Bree can hold it in the air and read it off.
So we have 36.8 degrees Celsius.
Now she can take the same probe and lower it gently through the water column. We want to make sure that we don't hit the probe against any hard surfaces. As she lowers it in the water column, she could take a surface reading, or she could take one closer to the bottom, which we know is approximately 2 meters in depth here in the boat basin. So Bree, what is the temperature in the water column?
So the temperature is 31.9 degrees Celsius.
So we also said that we can measure salinity. So what is salinity? Salinity is a ratio. It's the ratio of how much salt ion actually exists in a water column with all the H2O or water molecules. So Bree, what is our salinity?
Our salinity is 30.2 parts per thousand.
So that's telling us that there are 30.2 grams of salt for a 1,000 gram unit of water. 1,000 parts per thousand. Oftentimes when we're in the field, instruments may go down. A battery might die. What Laura has in her hands is known as a refractometer. This allows us to manually measure the salinity or salt content in a water column. Laura will demonstrate. What we want is a few drops of water on the optical lens with a plastic cover over it to try and eliminate air bubbles. Then you use the optical end where you can view a scale, and that will actually be in units of parts per thousand. So Laura, what parts per thousand did you get?
31 parts per thousand.
And Brianna had nearly the same. If you have aquariums, particularly saltwater aquariums at home, you may actually be using a refractometer.